Hello everyone, welcome to Mindspan Education. Today I'm going to start this new subject of DBMS and data warehousing as part of our complete Gate DA course that we have launched. So more detail about the complete course, you can go here at mindspaneducation.com. Here you will see all the detail about the course. We have already covered calculus and optimization and linear algebra as part of mathematics. And next, from mathematics side, probably probability and statistics will be taken up. And I'm taking this DBMS and warehousing as part of that plan. So more detail about the course, the subjects that are ongoing, subjects that are covered, and what subjects will come in future, and schedule, uh, probable schedule. Everything you will find here at mindspaneducation.com. You go here and check this out. Okay. Now let's start. In this video, this is not any lesson video. So in this video, I'm just going to give you introduction about the topics that I'm going to cover as part of this database management and data warehousing. So what are those topics and what are the key areas that I'm going to focus throughout this subject, and what are the key areas from where most of the questions are being asked in the exam for GATE DA and GATE CS as well. All the areas that we are going to see in more detail. And of course, the whole subject will be very uh, comprehensive. It will cover almost everything, but there will be more focus on the areas which are more important from exam points of view. Okay, so little bit about me. I'm Rajeev Kumar. I'm a working professional and I love teaching. That's why I'm doing this. So I hope I will be able to make some positive change in your life by delivering these lessons. Okay, so stick with me and join this course and prepare well. Okay, so let's start. This is the official syllabus given by the GATE DA Organizing Institute. Okay, so these are the topics that are mentioned by the official syllabus. Okay, this is a part of the cutout of the official PDF. So ER model, integrated relationship model, relational model, where we see tables and all those primary key, secondary key, foreign key, all these things. Relational algebra, where we see all the joining and everything. Then tuple calculus, SQL, a structured query language, how we write the SQL to retrieve the data from table, how we do update, insert, and all those things, how we write efficient queries, all these things we will see. Integrity constraints, what are integrity constraints, how we put on some columns so that erroneous data does not get into the table. All these things we will see. Foreign constant, uh, primary key constant, all those things, right? Normal form, 1NF, 2NF, all these things, 2NF, second normal form, voice code normal form, all these things we will see as part of this normal form. And then file organization. See, database means storing the data, okay? So overall, the data that we are going generating on our day-to-day basis through our devices, that needs to be stored somewhere, right? So that it can be retrieved again on demand, right? The more you see, more the technical advancements happening in the society, more data we are going to generate. So if you don't keep them smartly, then everything will become slow. If the retrieval becomes slow, search itself becomes slow, then all the devices working on top of that will become slow, right? All the application devices, everything will become slow. That's why this we need to understand and organize the data properly. That's why we are study this DBMS. And why it is part of GATE DA course? Because in GATE DA, what we are studying mainly is related to machine learning and artificial intelligence. But what is machine learning? Machine learning itself is a uh, like intelligence that you derive from the large set of data, training data. But if you don't know how to organize that data, how to keep that data, then you will not be able to understand the machine learning in any way, right? That's why we are studying this DBMS. And warehousing, what is part of this warehousing? Warehousing means you might have heard warehouse for Amazon, right? Or Flipkart warehouse, delivery warehouse, where they keep their stuff, right? So for data warehouse means where we keep large amount of data. If we, I will give you a comparative study. If you talk about 200 GB or 300 GB data for DBMS, then warehouse means in petabyte. Petabyte is like too much of GB, right? TB, and then on top of TB we get PB, PB, petabyte. In petabytes, like too much of data. How we organize that kind of data, right? Like if you take an example, YouTube, right? You see, you are watching this video on YouTube. That means on YouTube, volume of data is enormous. You can't even imagine. This is unimaginable, right? So how we store those kind of data? How we are keep those all data, archived data, so that on later on, when user do the search or sort operation that works efficiently, right? Or any machine learning algorithm that we run on those data to derive some logical information to utilize it, it should work, right? That's why this warehousing concept comes into picture. How to organize the data, how we slice it, how we drill down it to find out some relevant information. So that's why this warehousing. And everything that we see, file organization, indexing, data types, data transformation, everything is part of this data management itself, right? So normalization, this normalization, see again another normalization. There was one normal here, normal form. This normal form is different from this normalization. This is data normalization. This was relational database normal form. Okay, data normalization means we should not get the noise in the data. Like if data is in different form, I will give you an example. See, if gender is male and female. If we put M and F in the table, but we use 0 and 1 later on digit basis, then we convert this MF into 0 and 1. If there are MF somewhere G, then that means we did not get this data, right? Only M and F are value that are being converted into 0 and 1. These kind of thing where we convert the data in our desired format, and it's like washing and getting the proper data that we can process and get the information out of it. Okay, some relevant information that we need, that is called normalization of the data. All these things, discretization, sampling, how much sample we take, compression very important. If you have large data, then you need to compress it to keep it. Data warehouse modeling, like different schema that we use, okay, for multidimensional data models, that everything we will see. Data can be kept in multidimensional format. Like if there is a sales data, then one dimension will be how much sales are happening. Another dimension will be time, like 2025 sales, then 2024 sales. So time is another dimension. So how we keep these data in different dimensional forms, right? All these things that we are going to study as part of this subject. Okay, so let's see in detail what are the topics that we are going to study. Currently, I just gave you an overview. Now, let's see this detail. Okay, these are the topics that we are going to cover in this. See, first we are going to, of course, we are going to see what is DBMS, database management system, and why it is important from our point of view. Okay, so DBMS and what difference between file system and DBMS. In DBMS, we keep data in particular tables or some other form. In file system, we directly keep into the file. Okay, what is difference between them? Why DBMS is preferred rather than our file system? In some cases, file systems are also preferred. Okay, so this is again the official syllabus that I just talked about. Topic wise priority, we are going to see these SQL queries in very detail. There are various ways to write SQL query, different keywords, different ways to prepare the query, and writing efficient queries. There are many ways you can write a query, complicated queries, but some of the queries, they both will do the same work, but some of the queries will give you instant result, and some of them will take hours to give you the result. Okay, if your data set is large. So how to write efficient queries, how to write joins, outer join, inner join, left outer join, all those things, where clause, aggregate function, everything we are going to see in the SQL queries. These are very important. See, from gate point of view, weightage is very high. And this database management system is like, if you know the about the topics, then it is very easy to score the marks in the exam. Okay, very less likely to make a mistake. Okay, so also normalization, 1NF, 2NF, 3NF, BCNF, all these things we are going to see. Of course, relational algebra like uh, joints, different type of joints, all those things we are going to see. ER models, data warehousing, storing technique, B plus trees. These are indexing trees, which we keep when we have large set of data. Then we have to keep it in very a smart manner. Then only we will be able to retrieve them quickly. Okay, so B plus tree is a data structure that stores keys of the large set of data. Okay, we will see all these things, data transformation that I just gave you, male female example, all those things, and everything tuple calculus, these things are low priority, but we will see this thing also. Okay, what other thing in detail, if you see, we are going to see ER models, like what are the different ways to draw the ER model, and under that model, what we use different shapes to represent different components. So those shapes, what they mean, and when we convert the ER diagram into the relational model, then what shape becomes what, those things we are going to see. So it will become very easy for us by drawing just ER model and convert them in different tabular form, and keys, finding out keys, relation among these entities, all this thing, right? So entity, attribute, key attribute, everything, relationship, participation, everything we are going to see as part of this ER diagram. See, this is an example of the ER diagram. We are going to see in detail when we start the chapter. I'm just giving you overview currently, that you should get an idea that what are the things that we are going to cover as part of this DBMS and warehousing course. Now, again, the cardinality. Cardinality means what is the relation between different entities. Entities like one table and another table. A student, I will give you an example. See, if there is a student which belongs to a class, then there can be one student can belong to only one class, but that class may have multiple students. So a student and class are two different entities, but the relation between them is 1 to n. That means uh, class will remain one and a student can be many. One to many relationship exist there, right? Like this department to employee, one department can have many employees, but one employee can belong to only one department, right? Same employee cannot belong to multiple department, like that. Okay, now all these things, this is called cardinality. Okay, we have already seen this in set also, that is the same cardinality concept, but it applies in our tables and entities. Okay, and then ER to relational schema. That table that we are talking about is called relational schema. How we convert this ER diagram to relational schema? What are the basic rules that we follow? Okay, all these things that we are going to see as part of this subject. Okay, now relation model, different type of key, super key, candidate key, primary key, foreign key, composite key, everything we are going to see. What are these keys are, how we define it, what they mean, everything we are going to see. Also, we are going to see relational algebra operation. Relational algebra operation means when we apply select, when we apply project, the select means we are taking some rows from the table, from a table. Project means we are taking some column from a table. So entire row will come, but only few column will appear. Here entire column will come, but only few rows will appear. Best case is where condition, right? Where here what we write, select some columns, column 1, column 2, all these things. So here I will not dive deeper into these things. Okay, I'm just giving an overview. Joins, left outer join, right outer join, inner joins, Cartesian product, difference, union, Cartesian product, everything, these things we are going to see here in this subject, okay, in coming days. Different type of join, see, natural join, theta join, equi join, outer join, again, there are three type of outer join, okay, this thing we are going to see. Among all these, whatever is more important, more frequently being asked in the exam, we will see more detail about those and overview of the less important, like semi-joint, anti-joint. These things are not very popular and seldom, rarely being asked in the exam. So we want to focus much on these things. We will focus more on these things, right? As part of the course. When you go through the course, the lecture material, you will get to know what I'm saying. Okay. Again, tuple relational calculus are there. So this was relational algebra is a procedure query language. That means it tells database DBMS how to retrieve data step by step. So you can directly convert these relational algebra operation into SQL query. But this is tuple relational calculus. These are like sentence. You cannot directly convert this into SQL queries, direct conversion. But it describes, it gives you overview that what you want without specifying how. It gives you what you want to do, but you do not give exact detail how it will be achieved. But this relational algebra, it gives you exact details how it can be done, how it will be done. So when we write a relational algebra operation, you can directly convert that into SQL queries and it will run, it will give you exact results. But here directly you cannot convert. You have to think about what will be the corresponding queries, corresponding, what will be the corresponding queries. You have to again put your mind and think about the query separately again. Okay. So tuple relational calculus. This will give you exactly what you want to do, but not how it will be done. Okay. As part of the query. Okay. We will see these things. They are also hot topics. It is being asked many times in the exam. So we will see this also. Again, SQL, we are going to see SQL in very detail, how we construct the query based on our requirements. What is data definition language, data manipulation language. And again, DCL, TCL, not very important, but we'll see all these things also. But these are mostly, most of the our queries contains these data definition, data manipulation language. Okay, we'll see how we use this and how we construct the queries that involves these keywords. Okay. Then again, we will see aggregate functions. Very important. When we try to put some mathematics over the query, like summing the column, finding out average, finding out minimum, maximum, counting the rows, counting things, all these things. When we put these mathematical operation on the query, it is called aggregate functions. Okay, we will see how we apply the aggregate functions in the uh, query, how we write this kind of queries that involves aggregate functions. Okay, we use group by, we use having clauses. These clauses give us more control over the type of data that we are going to retrieve from the table. Okay, and again the joints, of course, the join. We will see how we use the joints in the query, how we'll write the full outer join, cross join, right join, left join, inner join, everything we are going to see. And multiple query, like their nested query. Suppose if we want to get the salary of any particular department, employees, then first we will employees whose name starts with, let's say, A. Then first we will write a smaller query that find the employee's name uh, whose name starts with A. Okay, and then we will take those employee IDs that we return, that got returned from that query, then put into a uh, upper query, like nested query. Okay, query 1 and query 2. In query 2, result of this query 2 will be fed into query 1, and then final result we will get from query 1. So these kind of nested queries, subqueries, we will see how we construct them. These are very, very important when we try to write some complicated queries, try to retrieve data uh, from the tables. Okay, in real life, most of the queries are nested only. Okay, so whatever you get in the exam, they will, they won't be very simple queries. They will be nested queries only. So how we write these subqueries and nested queries, we'll see them. And these are also some views, how we write views, triggers, stored procedure. This thing we will also see. And these are the things like when we write a view, that means we are actually not creating any physical table, but we are going to create a, by mixing multiple tables, we are going to create a view, means we are going to just logical table. We are going to create in logical table. That means on reality, this data does not exist in that tabular form that we are seeing on the result, but they are just programs. When we run those views, we get the data and it appears like a table itself. Okay, triggers that fires on particular operation, on insert, on update, all these things. A stored procedure, when we write mathematical formulas in the queries, a lot of formulas are involved, then we write it is it in the procedure form, so that we don't have to, it's like functions. We write a particular function that we can reuse whenever we want. Okay, so all these things also we are going to see as part of this subjects. So it is going to be very interesting. uh, this subject is very interesting and very useful in real life. Okay, when we work in the uh, real computer science domain, then these are the things that you use on day-to-day basis. This is what I am using here where I work. I'm using on day-to-day basis, writing queries and uh, making programs. Okay, all these things. Now also we are going to see these integrity constraints, like different constant that we put on the table. We are going to see all these things as part of this course. Okay, referential constraints, on delete cascade, all these things. These are the like conditions that we put on the table so that erroneous data does not get into table, or when we delete some data, then its referencing pointers should also get properly validated. Okay, now also see again the normal forms, first normal form, second normal form, third normal form, and then voice code normal form, everything we are going to see this. This is also very important topic from get to exam point of view. Examiners take very interest in this subtopic. normal forms. And very we see repeated question being asked from this topic. So we are going to see in detail how we write different type of normal form, or how we convert from one normal form to another normal form. Okay, all these things. Then also this functional dependency. This is also very interesting topic, that we write this functional dependency, and questions are also being asked from this topic. So we are going to see in detail this also. See, unnormalized data, then first normal form, second normal form, third normal form, BCNF, all this thing. Okay. I'm not going to give you detail about these things right now, because this video will become unnecessarily long. Okay. We will see details uh, when these topics come in our way. Okay, while teaching. So we will see everything in detail then and there. Okay. Now, apart from this, we will also see how we store the data, file organization, indexing, B-trees form, everything, heap file, sequential file, hash file, how we organize these files. They are basically the data structures that keeps the pointers to the data, so that our retrieval, uh, that is search, becomes very efficient. Otherwise, if you keep all the data in the filed form, you won't be able to get the relevant information when you need. Okay, so to make them those search operation efficient, we use particular data structures to store their pointers. Okay, this B tree does not exactly contain the data itself. They contain the pointers to the data blocks. Okay, data may be in the CD or somewhere in the files in some form, but the blocks, the data stored in the blocks, these blocks have referential pointers which are being stored in the B, B plus tree or B tree. Okay, then whenever we travel here, we look for pointers. So if we are looking for this data, we look for this pointer. When this pointer is found, then this data block is found. So that's how the search operation works in the database. Okay. So all this thing we are going to see how we create the indexes in the database in form of query, what they mean, how it helps our search operations, everything we are going to see, right? These are the examples of B-tree, and of course, and then data transformation means like data normalization. This is not DB normalization, okay, that I just gave you at the start of the video. This is completely different from database normalization, which is 1NF, 2NF. That is a different thing. And this is data normalization. Data normalization is converting data in particular form, okay, our desired form. All right, sampling, like selecting a part of the data so that we can train our models, machine learning models. Okay, data compression, different type of compression. When we do very high compression, then there may be losses of the data when we retrieve back. There are some lossless compression also. Okay, we'll see these things also. And then again, the second part of the this subject. First part was database management system. This was also second part only, in the purview of second part only. These comes under these data, high volume data only. Okay, this is second part. Second part is data warehousing. Data warehousing is uh, the ways, the intelligent way, where intelligent ways where we keep the data, large volume of data in petabytes, and based on those historical data, we make uh, knowledgeable information and gather knowledgeable information and use it to uh, give proper direction to our software. Like I will give you, if you keep buying stuff on the Flipkart, then you are creating large volume of data about you, about your choices that you make. In summer, you are buying this kind of cream. In winter, you are buying that kind of cream. All these data are being stored. So all those data which are stored are later on being analyzed, and informations are being derived, and based on those information you will get recommendation on those Flipkart app or Amazon app that this is summertime, and you are more probably like it is more likely that you are going to buy this particular cream, right? So and when you see that recommendation you are more likely to buy it. Okay, so companies use that information, use that historical data. Based on that they derive some knowledge and use that knowledge to recommend you something that you are more likely to go forward with, right? So this kind of information processing and storing that we handle large volume of data to mine information is called data warehousing. Okay, we are going to see that what are the processes, what are the ways where we store and retrieve those kind of data, where we do analysis, right? This is called OLAP operation. You might have heard analytical processing, where we do the processing by analyzing the data. Okay, so that kind of thing that we do comes under the purview of data warehousing, where we will see all the OLAP related uh, actions like roll up, drill down, how we do drill down. Since these data are very high volume, so we have to process it intelligently. Otherwise, it will become junk for us, right? It does not become junk; it becomes gem for us. We use wise ways to process this data, right? So slice, dice, all these things we are going to see as part of this data warehousing. Okay, and then different schema, how we keep those data and how we process star schema, snowflake schema, galaxy schema. There are different various ways we use this. Okay, how we keep track of these large information, archival information, and how we use it. Okay, and then the measures, categorization, computation, and OLAP operation, all these things that I just talked about, pivot, dice, slice, drill down, everything we are going to see as part of this data warehousing. So these are the topics in detail. I gave you the overview, kind of introduction, that what you are going to get as part of this subject in coming days, when all the topics are being covered in detailed manner. Okay, so this is going to be very interesting journey for you and for me also. Uh, just be with me and watch the lectures regularly and do the practice. As part of lecture, if you are not an existing student, then let me tell you some few more details, that apart from the lecture, I'm going to also provide the practice problems. With every lessons, I'm going to give 10 to 15 practice problems, so that when you study those topics that I have covered in a lesson, or two, three lessons combined, then you can practice it, so that you get the better idea of the things that you have learned. If you don't do the practice, then on surface you will think that you got it, but when the real in the real exam, when the those problems comes back to you, then you will face real hurdle while solving and finding the correct answer. So practicing is very important. So we provide the practice problem in form of quizzes, okay, as part of the lesson also. And also, I'm going to provide the uh, revision notes for one each lesson, or maybe one or two lesson combined in group. I'm going to provide the revision notes. Probably for each topic, I used to provide the revision notes, so that towards the end, when you do the revision, or you want to reference these learnings, you need not to watch these videos from a start. You can just go through the PDF of those notes, and you can get all the concise information uh, at one place, right? Okay, so that's it. I hope to see all of you enthusiastically as part of this database management and data warehousing course. So see you in the lecture. Okay. Thank you, everyone. Happy learning.